Welcome back. This is Prof G. This is the solution for question number 8 in our 9-question, 2.5-hour midterm exam. This is the Pac-Man keyboard input using the HID library in CircuitPython. We also have some capacitive touch going on. So here's the question, and here's the solution. So my students are tasked to build assistive technology, and they're going to be working with a partner organization at Boston College at the campus school, which is an organization for young children that have physical challenges and other developmental challenges. And so among the different things that they may be doing is creating special keypads and keyboards for students to enable them to play video games if it's otherwise difficult for them to work with other controllers. And so this uses the HID, or the human interface device input that we learned about in CircuitPython, to create a touch-sensitive keypad, and we want to imagine that they are using this to manipulate the up, down, left, right arrows in the Pac-Man doodle game. And so, by moving the Circuit Playground Bluefruit, we're going to set up 4 different keypads for capacitive touch to handle the up, down, left, and right arrow. And by touching those, we would imagine, if you were really building a keyboard, that might be attached to a very large keyboard, or maybe to some assistive technology buttons that someone could touch depending on their different abilities. But this sort of shows you, how we could use and manipulate the game by doing up arrow, up, down, left, and right, and sending input to the keyboard simply by dealing with capacitive touch and the 4 different alligator clips that I've got connected to my device. So you can see I'm controlling Pac-Man, and I'm not very good at playing Pac-Man. But the way that we set this up is this is the Pac-Man game that our students can try out their program on to make sure that it's working properly. They attach 4 alligator clips to A4, 5, 6, and TX. Remember, TX is the last capacitive touch pad on the Circuit Playground Bluefruit. And when touched, A4 does up arrow, A5 down, A6 left, and TX right. So you should write your code to be able to move up, down, left, and right when those things are touched. So this is the question my students faced. Let's take a look at the solution. So our students are going to work with Digital I/O, Touch I/O, and import USB HID, which is the input device to be able to use your Circuit Playground Bluefruit and act as a keyboard. So we're importing a bunch of other different components from the libraries here. You want to make sure that you do all of this import. And again, this is very similar to what our students had done in some learning exercises to prepare for their exam. Then they set up their keyboard. We're going to call it KBD, and there's only the US layout that's available at the time that I'm recording this video, but fortunately we're in the United States, so this works out well for us. Then my students set up the capacitive touch pads, and there are lots of different ways you could do this. You could set these up as 4 separate devices, but the technique that I'm showing you here is a technique where we create a list of 4 different touch pads. And the way that we do that first is, well, we set up a list called pads that has the 4 different locations on the board of the 4 capacitive touch pads that we want to use. We could add more capacitive touch pads here as well if we needed to do that. And then the way that we set this up is we start out with an empty array touchpad, and then we go through the length of the pad array, and we append the touch in at pad I. Now, I subsequently showed my students too how to iterate through an array. So one of the things you might want to try out is to see, hey, instead of going through 1 through the range at length of pad, could I iterate through the pad list? I'm calling it an array. It's really a list. It's very similar to arrays in Swift, so that's why I make the mistake. But yes, this is a list data structure. Could you iterate through the list as well? So say for pad in pads, and then just put your pad in here. You absolutely could. You might want to try that out on your own. But this was the first technique that we used, and this works out great. Now, I also set up a list with the 4 different keys, the up arrow, down arrow, left arrow, and right arrow key. And then in our while true loop, all we need to do is we need to go through the range of the different pads in our touchpad. You could also iterate through this as well. Actually, you couldn't iterate through this as well because we want to use the index value I not only in touchpads, but also to access the key that's associated with the touchpad that we're pressing. So this is what we do. We go and we take a look at all of the different touchpads. We see if any of those touchpads has been touched. So that's why the touchpad, individual touchpad, if it has a true value for dot value, then we know it's being touched. Then if it is being touched, what we do is we call keyboard press, and we pass in the particular array that's associated with that touch. So if we touch 0, pad A4, we want to do up arrow. If we touch 3, which is board TX, we want to do right arrow. That's how that works. Now afterward, we make sure that we release all keys, and while the touchpad is being touched, we don't want to send multiple presses, so we say while touchpad I.value, we'll just continue to pass in there. So again, we don't want to set a bunch of different passes over and over and over again. If you did, you could remove this particular value, but especially in working with students that have physical challenges and touching pads may be difficult for them. They may linger on the pad for quite a bit of time. We just want to make sure that one touch is going to be able to access and activate that particular touch. So that's our solution to problem 8. Hopefully you got that. If not, now you've got the solution. Try it out, make sure that you've got it down, and we've got one more answer for our test in the upcoming video.